Hi, myself is Rajiv Shah. I work for a company named Gigaspaces, and today I am going to demonstrate how Gigaspaces in-memory computing grid is helping to maximize the performance of modern payment system. So, as you guys have observed in past few years that more and more companies and more countries are going towards the cashless society. It means that as cashless society increases, there will be many more transactions going to happen using some type of system. So, they need speed and also they need to manage the velocity. And as of now, the prediction is that there will be trillion dollar of payment going to happen in the next 1 year. So, here is our main product line. We have two major product line. One is the Insight Edge, which is our flagship product, which includes in-memory data grid and also Spark and analytics part of it. And second one is a ZAP, which is our core in-memory computing grid, which is 18-year-old product. And by the way, both products are available as a open source for developer to try it out, but most of the features are closed source feature. And if you guys have interest, we can go in a detail. And as you can see in right side that we have so many Fortune 500 customers and ISV customers. Today I am going to talk about this payment use case, but we have a customers in many different sectors such as financial, telco, and here we are demonstrating only 5 sectors, but we have a customers in many more sectors. Here is a small list of customer which we are allowed to use and publicize, but we have many more customers which we are not allowed to do, but this can just give you idea that okay, like major banks like Goldman Sachs, SocGen, Morgan Stanley, Bank of America are customer. Same way in a transportation, CSX and others are customer. Also we have a trading companies, healthcare companies, we have a bunch of ISV partners. What we have observed that as data is exploding, 74% of company wants to be data driven, but only 23% of having success, and we will demonstrate how to increase that percent, and you want to be in part of 74%. So, now when you have a data, normally you have a two type of data. One is the historical data and second is the real time data. And what we allow to do is that we allow you to do real time analytics in a grid or real time transaction processing in a grid, but because we have a Spark built in, we also allow you to connect with the different data sources and have your historical data and real time data combined together and give you the results. Also as a part of our product, when I will go into detail, I will demonstrate that how can you store your cold data and hot data in a grid by reducing your TCO. These are the three major components we help, or these are the three main use cases we help, like how can we help the real time transaction, how can we do the analytics on historical data, and we allow to connect to many different data sources. It could be any traditional RDBMS, NoSQL, S3 or any other storage, Cassandra, or any other data sources you can think of. So, as a part of our product, what we allow to do is that we allow you to access your big data and get the insight out of that. Then once you have better insight, how can you convert that better insight to the real time insight, because most of the analytics application, when they are doing analytics, they have a slow loop back between their analytical application and transaction application. So, specifically in a think about the financial world, if you have any slow loop back, then what happens that you won't able to take action on the latest price feed, and that is what we are resolving as a part of our product. These are the main challenges for the payment application, and digital commerce is a key way to acquire the customer and develop the relationship and drive the revenue and cost, and this is how we are going to do it and solving the problem. So, the first one, as you see, that focus on how latency and high throughput we can provide using our product. How can we combine batch and real time? How can you do the advanced analytics out of it? And how can you get the highest reliability out of it? This is the high level overview of our product. So, we support full transactional system, but on top of that, now everybody would like to do the analytics and also deep learning. So, to fulfill that requirement, we have a full integration with Spark. We also have a integration with TensorFlow, Caffe, Torch. Even we have a strategic partnership with the Intel, and we have a full integration with Intel Big Deal, which is deep learning library run on a CPU versus GPU to reduce your cost. Here are the different storage we are supporting. This is the overall architecture of about our product, and as you see that we have so many features. So, we have componentized overall features in a few different categories. The first one is our in-memory grid, which is our core component, which exists in a market from 18 years, and many financial companies are using from many years. So, part of our in-memory grid, what we have it is that we definitely have a caching solution, which is used by everyone or needed by everyone. But on top of that, the features we are having is that instead of just having a key value pair, we allow you to store different indexes just like any other database. The benefit here is that, like in a database, you can assign primary, secondary index, you can assign composite index, you can do everything here. So, that allows you to run different queries with same performance. The next benefit is that event processing. So, in a database, whenever you use database, the one of the benefit of database is that you can write the triggers over there. So, whenever you do any transaction in database, it allows you to kick off store procedure or function on top of it. So, we have a same feature in memory. We use the terminology event processing, but what it allows you to do is that whenever you write any of your data in a grid, it can kick off business logic. So, when you are using database, it can kick off the store procedure, but the store procedure context is still database. You cannot make call to out of it. Whereas, benefit here is that you can make a call to full fledged business logic. And if I give a specific example of financial world, such as whenever you receive the stock price for Amazon or S&P 500, based on that it can kick off the order management. Initially, it can kick off your analytics system. What it will do is that it can predict that, okay, based on this price, would you like to, do you need to send buy order or send order? After it take a decision, it can kick off your order management system, connect to your exchange and send order. So, now without any manual intervention, you have a full fledged order management and algorithm trading system part of our grid. The next benefit here is that part of our product, we also have a web container built in, and because of that, now you do not need to go out of JVM. So, you do not have any network latency, nor you need to worry about serialization or deserialization. So, when your business logic kick off, it kick off from the same JVM. So, without latency, you have a better performance. The next benefit over is that as a part of our product, we support different programming languages such as Java, C++, .NET. There are products which support many different language, but most of the time what happens that you ends up with writing some type of wrapper object yourself. So, it means that you need to worry about converting your Java object to .NET object or vice versa, or same way Scala object. What we allow to do is that we provide necessary wrappers. So, it means that when your .NET application or Java application needs to connect to the grid, it does not need to worry or need to bother about that what type of objects are in memory. You just connect to the grid and ask that you need .NET object, and we take care of everything. So, you have no burden of conversion. Now, in past few years, Spark become a de facto for analytics. We have a full integration with Spark, but also what we observe is that when people are using Spark, most of the time they are using Scala. Scala, end of the day, it's a JVM. So, what we have done is that now instead of just .NET and C++, Now we have also fully interoperability between your Java object and Scala object. So it means that if you write a RDD or data frame from a Spark, you can just read same object from a Java without worrying about that's RDD versus data frame. The next benefit here is that, as I was saying, that we have a web container built in. So what we allow to do is that instead of just you are using our product as an in-memory data grid, you can also use our product to deploy the microservices. Now you can think of that, okay, microservices, you don't need any application server, you can just run it over that. But most of the time when you are going from your monolithic application to microservices application, the major problem you are having is that now you have modularized all your components. So it means that there will be always a case that one of your component is having heavy load versus other part. It means that that particular component would be bottleneck or will be cause for the performance penalty. So what we allow to do is that when you install that application, you install as a stateless PO, and because of that you just define your SLA, and based on your SLA, whenever, and we keep monitoring your component. So whenever we see that, okay, there is any queue or there is any bottleneck, we take care of dynamically scaling out or scaling down that particular model. So that way your application still have a same SLA even though you went through microservices architecture. The next one is the RPC and map reduce. So as you guys know that when big data came, people start using map reduce, or people become aware of map reduce, and when they start using map reduce, one good part was that they can start using the data stored in HDFS system, but still they were able to use only for the batch processing. And to overcome, Spark came in a light, but we have that concept available in our grid from many years. What it means that for your transactional application, you can still distribute your module as a map reduce in a different components or different cluster of our grid and get the data back. We use the terminology called distributed task. So that way from your client application you just make a call, it pass your jar file to the individual partition, do the communication and get the result back. Also now when we are talking about its in-memory grid, one of the common question we heard is that, okay, now your product is an in-memory grid, what happens when your JVM goes down? Do I need to rebuild our cluster? So answer is no. What we allow to do is that we allow to have a n+1, which is the minimum requirement we suggest to provide a redundancy, but you could have a n number of additional redundant component or a redundant backup partition to overcome that situation. And the way we work is that whenever someone writes a data in a primary partition, it take care of writing same data in a backup partition, and based on your tolerance it could be synchronous or asynchronous. So whenever your primary JVM goes down, what it does is that our management service will just point to the backup and it just change of responsibility. It means that there is no data transfer happening between primary and backup. It means that there is no performance degradation and still your SL is as is. The next benefit here is that we also have a auto healing. It means that whenever your primary goes down, your backup took over, but now you don't have any more backup left over because that become a primary. So we make sure to find out the necessary hardware resources, start the new JVM and assign as a backup. So within a few millisecond to second, based on the amount of data you have it in that JVM, you have a redundancy available right over there. The next benefit here is that we have a linear scalability, because this is in-memory data grid. It means that as you increase your cluster node, it keep improving your performance without any degradation. Not only that, the way we do is that whenever you start your cluster, you define the number of partition in upfront. So it means that whenever, let's say you started your grid with a 4 node cluster and each one has a 200 GB of data. So now you have a 1 terabyte of data, and you see that, okay, if you are an e-commerce company, you have a few days every year where you have an extreme amount of load. So on those days, what you do is that you just start a new JVM instance with a higher capacity, and during that, what it does is then we have a scripts available, so that way you can take down your backup. So now your bigger JVM become your backup, you move your data, and then your primary goes down. So for application without any downtime, now you have a bigger grid available. And the benefit of that is that you still have a same 4 number of partition. It means that you don't need to either recalculate your hash value nor your routing key. So it means that there won't be any additional data transfer going to happen between them. The next benefit is that just like a database, one of the major thing we have observed in a world is that whenever you use any database such as Oracle, you always need to have a primary and production and disaster recovery. Then you need to worry about SRDF or some type of technology, or you need to buy Golden Gate or any other technology to replicate the data between your production environment and DR environment. Whereas what we do is that as a part of our product, we already provide the multi data center WAN replication feature. So it means that now you could have a live grid between your production and DR. So whenever your production goes down, your global site load balancer change routing to the DR, and your grid is ready over there to serve that. We also have a many customer. What they do is that they use the active between primary and secondary disaster recovery, which is almost impossible for the traditional database, because there won't be, it won't have enough data available or accurate data available. That's why they always have a return to operation, one of the requirement. Whereas here they have a full-fledged prod and DR active. The next benefit here is that what we observe is that in past few years, after MongoDB came in a picture, people would like to start storing data as a JSON or BSON object. So as a part of our grid, we also support JSON and BSON object. Also we have a customers in an insurance company, and what we observe is that for insurance company, geospatial query is one of the important thing, because whenever there is a tornado or any natural disaster going to happen, they would like to know that in what radius that is going to affect and what could be the loss they are going to have it. So that way they can measure their PRN or manage their risk in better manner, or sublet their insurance or sell their insurance to other company to make sure that they don't have a big loss. And to overcome that, what they do is that they can use our product. So you could have a regular POJO objects written in your grid, and using the geospatial API and using our web interface, you can easily able to figure it out that, okay, suppose in North Carolina when the hurricane happen, you can see that how many houses are going to be affected by that and what could be their insurance penalty, and they can take that in a measure in advance and figure it out that how to manage their business. Here are the few different options for the data storage. So in past few years, now companies are start using big data, and now when you would like to start using big data for in-memory grid, one of the common question we observe is that, okay, I cannot have everything in a RAM, otherwise our cost will be skyrocketed. And also another thing is that they may not have all their data as a hot data. They can afford to have some type of performance latency for their cold data. So what we allow to do is that as part of our product, you can define that which data are your hot data and cold data. Based on that, on using the configuration file, you can define that what data will be stored in a RAM versus remaining cold data as a part of any type of storage, but still it's part of same grid. It doesn't mean that it's a just flat file. You have a still one big grid consist of RAM and some type of storage. That storage could be SSD or it could be SAN, NAS or any other storage devices. Now one benefit here is that even though your cold data is stored in SSD storage, your indexes are still in a memory. So assume that you have loaded your HDFS data. In normally NoSQL data, one of the thing is that you have a hundreds of column in each row, but still you could index only 3 or 4 column out of that, and those indexes are stored in memory in a RAM. So it means that whenever you query your data only for those index column, it never ever have to go to the SSD storage, whereas it's return data only from RAM. So it means that those query will perform in amazingly fast. The next feature we are having is a persistence. So now we are talking about in-memory data grid. It means that you definitely want to persist your data in case of any hardware failure or any hardware reboot. So what we allow to do is that we have a Hibernate configuration available. So just using some type of Spring configuration or XML configuration, you can define your endpoint, and based on that endpoint, it can write a data to any type of persistent storage. It could be RDBMS, it could be MongoDB, it could be any other Cassandra or NoSQL database. Also, what we observed in past few years, people would like to use the in-memory data grid for Spark. Now, one of the common questions we heard from the people is that Spark itself is an in-memory data grid. Why would we need additional in-memory data grid on top of that? So as you guys are like whomever has used Spark, Spark itself is amazingly good in compared to MapReduce, but still it has its own limitation, such as because of Spark is a distributed framework and it has a lazy loading. It means that what they have done is that to accommodate that lazy execution, they have made RDD and data frame immutable. So and most of the time you are using Spark with some type of big data. So assume that okay, if you are loading 500 million objects from your HDFS storage, now once you store that data in as a RDD or data frame, and you would like to modify and leave 10 rows out of that, what you will end up with recreating either RDD and data frame. It means that you will waste lot of compute cycle. Not only that, there will be heavy GC going to happen over there, because now it has to garbage collect all your RDD and data frame. So what we do to overcome that is that we have overridden RDD data frame data set and other Spark related API. So it means that now there is an additional method available called RDD or data frame dot save to grid. It means that it will store that RDD or data frame in a grid. So now your Spark worker has a very thin JVM, and also your data is stored in an in-memory grid. So now benefit over is that now your data is stored in a grid. So the first and foremost benefit is that Spark itself or RDD or data frame has no concept of indexing. So when you do RDD or data frame dot filter, the way it works is that driver node send a task to individual worker. Each worker go through row by row, accumulate the result and send that result back to the driver. So it means that when you have 500 million objects, it means that it has to go through every single row. Whereas here, when you are using our grid to do the same thing, benefit is that our product already has an indexing feature for many years. We allow you to do same thing. So when you create the case class, you can define all your query clauses as indexes. So now your grid, your RDD and data frame is stored in a grid. So when you do RDD or data frame dot filter, it does the predicate push down, and because of predicate push down, now our engine is responsible for the querying. So it means that assume that let's say if you have same example 500 million object and you have index your data based on a symbol, and that symbol is very thinly traded and that has like only 1000 row out of 500 million objects. So it means that you are going to say like you are going to have a query performance between 30 to 100 times. We have seen insane number of percentage. We just put 30 times because that looks reasonable, but it's really based on what type of data points you have it and what type of indexes you have it. The example I am giving, if you have like a 500 million object and out of that there are only 1000 object matching that, then performance will be extraordinary over there. The next benefit here is that because we store RDD and data frame in a grid, benefit here is that now that is not only a mutable, but you can share that RDD and data frame across different jobs. So, the way Spark work is that once your job is done, your RDD and data frame will be garbage collected, and when you start your next job, you will have to reload your data and go through the same process, whereas here your data is already there. So, you are avoiding all boot up time, and your application has to start worrying about only the execution time. The next thing is that we have a full integration with Intel Big DL, and because of that now you are able to do the deep learning with the full analytics. We do not have enough time, but if you have any use cases about deep learning, feel free to contact me and I can give a full demo about that how can you do automated call routing using the deep learning and natural language processing. One of the thing another we observed over a time is that more and more companies are using some type of BI tools such as Tableau and MicroStrategy. That is one of the most common used tool. And what was happening is that whenever they used to run a query, they always have to go to the database. It means that from our grid, using the mirroring module, it write a data to persistent system and then you query against that. But now we have a full fledged SQL support. So, now you are able to run your query against in memory grid. We already had our cluster management tool, but again in past few years what we observed that more and more companies are using some type of Hadoop ecosystem, and because of that they already have a in-house expertise or Apache Zookeeper to reduce the burden or avoid the learning curve. What we have done is that we have also added the Apache Zookeeper as our cluster manager. So, that way you can also manage our cluster just using your existing Apache Zookeeper product. One another benefit is that our product is a software based product. It can run on bare metal, it can run on a virtual machine, it can run on any cloud. Not only that, but in past few years what we have done is that we have made our product available on a Docker hub. So, you just write a 2 line of code, we have a documentation available. So, if you have a Docker engine available, you just write a 2 line of code and it will download the Docker image and you are able to use it. We also have a full Kubernetes support. What it means that initially we were using Kubernetes just for the orchestration, versus now we have a full Kubernetes native. It means that now Kubernetes is able to manage resources, and also using your pod and Docker you can manage your environment. Also, one of the use case we are solving many times is that there are many companies who are using Lambda architecture, and one of the limitation or Lambda architecture is that you need to manage 2 separate code base, one for the batch processing and second one for transactional application. And then if you have any use case where you need both data, then you need to write additional wrapper out of that. Whereas what you do is that if you use our product as a part of that, we simplify your Lambda architecture, and as you can see that here there were so many components, it has been reduced by one single component. So, now you have a less moving part and still you are fulfilling your need. And also on top of that, what we do is that whenever you have a Lambda architecture requirement, our product will be responsible to get the real time data and also analyticals data and have a report out of that. Here are some good things written about our company for different publisher, which is known like Frost and Sullivan, 451 Research, Gartner, and I am going to talk about this particular use case at high level. So, if you can see that we have an existing customer who is using our product to solve the fraud and money laundering use case, and they are ingesting 4 terabyte of data daily, and they are able to handle 1.5 million event per second. And if you see that in this architecture, it's very simplified architecture. This is your client, this is the transaction feeder, everything else is managed by Insight Edge, and it connects to the Cassandra or another ecosystem. So, I will just stop over there, and now it's open for any question or yes.
So, I'm comparing with Apache Ignite. They have something called the compute operation through the AD. So basically, wherever the data access, you do the computation on that particular node. So do you have a similar?
Yes, that's a really good question. So, the question is that Apache Ignite as an affinity concept, do you have it? Yes. So, what we do is that we always co-locate your business logic and data logic together. Not only that, when you design your object, POJO object, at that time you can define that what is your routing key and query. So, that way it coexists over there. So, it means that it does not need to go over the network. Not only that, you are avoiding the serialization and deserialization. Yes, sure.
Another question. So if there is another persistence layer and you have in memory data grid, so how do you keep both of that in sync? Are there different options available?
Yes, that's a really good question. Yes, we do have a different option. Now, first of all, our feature for the persistent is not mandatory, it's more of a feature if you would like to use it. And many times you could still have a Oracle as your database or any other database. But what many company has it, we have one of the major airline customer. The one of the problem for them is that whenever they reboot their grid, they have to communicate or coordinate with so many different groups just to get their data, and it takes almost 3 to 4 hours. So, what they do is that they use our memory extend. So, in case they just want to reboot that grid, but does not want a new data. So, at that time using our memory extend product, they can get the same data in less than 8 minutes, and also they can avoid all the coordination. So, again it is more of a feature, but not requirement. But also if you need it, you can persist your data in a both way. It is not either or, you could have it in a both way.
So if the structure of a cache changes,
Mm-hmm.
right, how do you migrate from one cache to another cache?
Good question. So, this is also one of the common problem we observe with our customer. So, what we have it is that we have a different type of API available. If you have like a pure SQL database, then you can just use plain vanilla POJO. But if you have any NoSQL database as your persistent or data source, then POJO does not work well. So, we have a concept of document API. So, it store all your data just as a key value pair. But to overcome that, we also have a hybrid approach. So, it means that what you can do is that you can use POJO and dynamic properties together. So, if I give a simple example, let us say if you have a person object, over there you know for sure that first name, last name, address and phone number will be there forever, and those are the column you are going to query. You can have that as a hard coded or a getter setter, but remaining field which you just need for read purpose, not a query, you can just use a dynamic property. So, that way whenever there is any change in your database, you do not need to even restart your grid will take care of managing that. If you would like to talk about any of your use case or any pain point, let me know.